The Rock Whisperer. Do you hear the earth talking to you?
Unit 7 continued. In this section, we're going to talk about erosion. 7-5. So erosion is going to be the movement of the material. We've started talking about how rocks can be broken down through the chemical and physical processes, and now we're going to talk about moving that. And that rock or soil that gets moved is what shapes and sculpts the earth. So we can see in these two different pictures how that happens. In the picture on the right, we can see there's a hole in the rock here. There's an opening on the top, and that the earth is going to be lowered as that material is being moved. Also here on the left, we can see that because of flooding, that part of the farmland has been eroded or washed away. So there's three main agents or ways that the soil, broken down rock, is going to be transported. It could be transported by water, it can be transported by air, or it could be transported by glaciers. The driving force behind all of these is going to be gravity. We have that downward force. So the soil and the rock are what is going to be transported in those. We can see here on the top a picture of Niagara Falls, picture of the wind, probably from the Midwest with some wheat, and then here are mountain scenery on the bottom with a glacier pushing the soil forward. So when we talk about gravity and things being moved downhill, we're talking about a mass movement, a large amount of material being moved. We're talking about slope. How steep is the land? Now this is something you've also done in math. You've done change in y over change in x in order to calculate the red line, which is slope. We can see in this next diagram right here that we could calculate the slope and find that the slope for A, B, C, and D are all going to be slightly different. And hopefully you can see just by looking at them that B is probably going to be, if we calculated it, going to be the steepest slope, where D is going to be the most shallow. So we can expect more material to move from letter B than from letter D. Now, the steeper the slope, we can run into some dangers at times. Those dangers can be landslides or mudslides. When we look at the picture here on the bottom, we can see that a landslide has occurred. We have a really steep slope here in the background, and because of the excess water, there was a large amount, mass movement of land. We can see that that land has moved down in this area that looks brown. There were once houses or buildings in that particular area. What helps to determine that is what we have in here in our last picture. We can see that the discharge, or the amount of water that passes through a given area in a given amount of time, is going to help determine the amount of material that can be moved. And we'll use a graph from our reference table to help talk about that. But in this particular diagram, we can see a cross-section of what the stream looks like. We see the land, the rock, top of the stream, and the bottom of the stream. Well, in order to figure out how much water is going by, we have to divide these into a bunch of rectangles. If we can find the area of one rectangle, again, area is the length times width, in this particular case, how deep the stream is, divided by a particular width of the stream. Then we need to figure out the discharge. And the discharge is the amount of water that passes through that area in one time. We need the velocity. How fast is the water moving? Past Regents question has often asked, how would you determine the velocity of this stream? Well, if we look at this back line here and this front line, if you were to drop an object, time how long it took to go from point A to point B, and then divide by the distance, you would be able to calculate the velocity. If we know our area and we know our velocity, we can calculate the discharge. When we talk about erosion and we talk about material being moved, and we've mentioned this in class already, we can talk about transported sediments or residual sediments. So Long Island is made up of transported sediments. These sediments were brought here by glaciers. Glaciers pushed, scraped across the ground like a bulldozer, carried this from where the parent rock was, and deposited them. And then the glaciers retreated and moved backwards up towards Canada and further north and left this material behind. The same is true of Cape Cod. Where residual sediments or soil is going to be if we have bedrock that's down here deep in the earth, and over time we have all of this rock that is going to form, or the soil that's going to form, I should say, and it doesn't move, it stays in place, the soil on the top, the humus, the topsoil, the soil, has the same characteristics, same mineral composition as the rock that's on the bottom. So there are, and I've listed 8 of them, main types of moving water. You might be able to come up with more than that. I've listed them here. I did not put pictures up. I figured to make this slide a little bit too confusing, but a stream, a brook, an ocean, a river, a pond, a sea, a swamp, a lake, all different types of water. They're all moving and flowing, some of them faster than others, but we can tell that those are going to be agents of erosion. They're going to help to move the soil. And the last slide we have here is, how do these sediments get obtained? How do they get brought into the water so that they can be moved? Well, one, and we've talked about this with the water cycle and climate, we can talk about runoff. Rain falls in the hills or mountains, goes into small streams or brooks, eventually into bigger rivers, flows into creeks or larger rivers, as I said, into lakes or ponds, and eventually back into the ocean. So it can carry that material. Mass movement is going to be like we showed in the couple slides earlier. We're going to have a large amount of earth that's going to break off because of underneath the boundary between the light brown and the dark brown here. That particular boundary, there's going to be a weakness, and the land is going to slide down the hill, and eventually when that slides, it will get put into some sort of body of water and carried on further. Then the last one is abrasion. When rocks and stones or pebbles are taken and they're bounced, rolled down a hill in water, and then the edges break off and we wind up with smooth rocks and stones.
Don't forget to listen to the earth. You just may hear it speak.